When finding the inverse of function, it has to be a one-to-one function. So you can see the following two examples are parabolas. So if we restrict the domain, we can turn these into one-to-one functions and then find the inverse. So the first function we've got from 2 to infinity of x minus 2 all squared plus 3. So let's do a quick sketch, and we've got a turning point at 2, 3, which would normally be a positive parabola that would come up from the top left and go across to the top right, like this. Now because we're going from 2 to infinity, we notice the turning point's at 2, so we're just going the right hand side of this parabola. The next thing to remember is that the inverse is actually a reflection in y equals x. So let's do a little diagonal line like this. And that point 2, 3 will become 3, 2. And it'll go up like a positive root graph. So that's the top half. The next thing to do is find to find the rule for the inverse, we're going to first write our original function in terms of x and y. So y equals x minus 2 all squared plus 3. And then I'm going to swap the x and the y's. So I end up getting x equals y minus 2 all squared plus 3. And then we need to transpose, which means make y the subject. So let's minus a 3 over the other side, which will give us x minus 3 equals y minus 2 all squared. And then to get rid of the squared, we have to get rid of the square root of both sides. So I get the positive and negative root x minus 3 equals to y minus 2. And then the last step is to get the 2 to the other side. So I end up getting y equals to positive and negative root x minus 3 plus 2. And now if we look back at our original graph, we were only taking the right hand side of the function. So we're actually only going to be interested in the positive root. So we want the reflection of that right hand side, which would give us the positive root x minus 3 plus 2. So let's write this in the proper inverse notation. So f with a little negative 1, so the inverse of f with respect to x equals to the square root of x minus 3 with a plus 2 on the outside. The last step is to find our domain and range of the inverse. So our domain of the inverse and the range of our inverse. The easiest one to spot first is the range of the inverse, because it is the domain of the original function. So the original function had a domain of 2 to infinity, so that is the range of the inverse. Looking at our graph, we can see the domain for the x values of the inverse graph, that pink graph, is going from 3 onwards. So our domain would be 3 inclusive to infinity. This next question is similar, that it's a parabola with a restricted domain to make it a one-to-one function so we can find its inverse. However, this time the domain given won't actually be at the turning point, so it'll look a little bit different. So same procedure, let's do a quick sketch. X plus 4 all squared plus 6. So negative 4, 6. There's our turning point. We can see it's going to cross up here. So we want to find where does it actually cross the intercept, that point there. So if I sub in x equals 0 into the original equation, I've got 0 plus 4 all squared is 16, plus 6 will give me 22. So that is my y-intercept. So that's the value where it crosses the y-axis. So just like in our first equation, our first question, we're going to find the inverse of this. So it'll be a reflection in y equals x, so that point 0, 22 becomes 22, 0. And when we mirror that across, we're going to get that part of the graph there, which again should look like the positive root graph. So let's write our equation in terms of y and x. Y equals x plus 4 all squared plus 6. Swap the x and y's, which will give me x equals y plus 4 all squared plus 6. And then let's rearrange to get y the subject, or transpose. So we put the x. So I end up getting y plus 4 all squared equals x minus 6, square root both sides, which give me positive and negative root. I'm only interested in the positive root, remember, So look at the top part of it. So I end up getting y equals root x minus 6 minus 4 outside. And then putting that into my function notation, the inverse of f of x equals root x minus 6 minus 4. And then lastly, to find the domain and range of the inverse, the range, remember, is the domain of our original function. So from 0 to infinity, we can put that straight in. And then when we look at our graph, we'll see that the graph of the inverse, the pink one, is going to go from 22 to infinity. So it'd be a square bracket inclusive to infinity.